Hello and welcome to Empowered Learning. This video will be about finding equations of lines, and these lines will consist of vertical lines, horizontal lines, parallel and perpendicular lines, as well as just trying to find the equation of a line where you have the slope and 1 point, as well as when you have 2 points. So we're going to start off with some relatively easy ones here. First thing I want to mention is that whenever we have a line that is vertical or horizontal, there are a few properties that we need to understand. Any vertical line, whenever we express the equation for that, will always be x equals a number, okay? And for a horizontal line, it is always y equals a number. And so what the equation of a vertical line says, it does not matter what y is, x is always going to be this specific number. And similarly, whenever we talk about a horizontal line, that horizontal line equation says it does not matter what x is, y is always going to be this. And so I'll use examples 5 and 6 here to make my point. So if we want to find an equation of a line that is a vertical line that goes through the point 7, 9, then let's say if we were going to draw a graph here, and let's say this is 7, this is 9, and we have this point here. Of course, a vertical line is going to look like this. The one thing that you see in common with every single point that is going to be on this particular line here, regardless of whether we're at the point 7, 0 right here, or 7, 1, or 7, 2, is that all of these particular points, again, if I say 7, 0, or 7, 1, or 7, 2, we see that all of these have the same x coordinate. So in this case, it does not matter what my y values are, whether I have 0, 1, 2, we know that x always has to be 7. So because of that, we know that x equals 7 is the equation of this particular line. Similarly, if we look at this horizontal line, we draw another graph, and let's say this is the point 3, 0, and we have a horizontal line that goes through that. Now, of course, that's just going to be at the x-axis. And of course, any point that is on the x-axis, just like the point 3, 0 has, y-coordinate is always 0. So in this case, it does not matter what x will be, whether it's going to be the point here, I'll just move that there, whether it's the point 0, 0, which is right here, which I'll put here, or if we have another point here, negative 1, 0, negative 2, 0, does not matter. All those things pretty much the same. Y coordinate is always 0. So for here, the equation of this particular line will be y equals 0. In short, what I like to say whenever we deal with vertical and horizontal lines is that if you're given a point, then vertical line is always going to be x equals whatever the x coordinate is for the point that's given, and horizontal line will always be y equals whatever the y coordinate is for this point. So if we looked at this point a little further here, let's just expound upon this some. If I wanted to find, instead of, let's say, a vertical line, a horizontal line that goes through the point 7, 9, then in drawing that line, it would look like this. But the actual equation would be y equals 9, because on this horizontal line, it does not matter what x is, y is always 9. Similarly, if I wanted to find a vertical line that goes through the point 3, 0, then of course going through here, this would be that line, and it does not matter what y is, x would always be 3. So that's just to give you some variety of examples there. All right, so let's go ahead and move on to our next set of questions. All right, so now what we want to do is talk about lines that are parallel and perpendicular. So the main thing that we want to remember here is that lines that are parallel to one another, and I'm just going to draw some random lines here. Parallel lines do not cross, and that happens whenever the slopes of both of those particular lines are the same. Okay. Whenever we talk about lines being perpendicular, what we're saying is that they intersect at a 90-degree angle. Yep, sorry about that. My page jumped there, but we're talking about having this at a 90-degree angle here. And so the thing that we know about, let's say, line 1 to line 2 is that the slope of line 2 would be the negative reciprocal of the slope of line 1. So for instance, if the slope of line 1 was a negative 2/3, then that means the slope of line 2 would be a positive 3/2. Because when we take the reciprocal of negative 2/3, it would be negative 3/2. And of course, the negative of a negative is positive. Okay, just to kind of give you a frame of reference there. So now, if we look at this, we want a line, equation of a line that is parallel to y equals -7, and it goes through this point here. So I'm just going to draw this so that you can conceptually see how I'm coming up with the answers that I am, but we could answer this directly. And so after I kind of demonstrate conceptually what's going on, I'll show you the short way to get to the answer. All right, so let's draw a graph again. So we're dealing with the line y equals -7. So if we draw that just in general, that would be somewhere over here. That would be a horizontal line. And so we want a line that's going to be parallel to that, that goes through the point 4, -5. So here, we're going to say this is at 4. We'll just say that that's -5 there. So that point would be here. And since it's going to be parallel to it, it's going to also be a line that is horizontal. So if this line here is y equals -7, then this other horizontal line here would be y equals -5. And of course, the answer to this question would be y equals -5. The reason why it would be y equals -5, because again, we know that it does not matter what x is, y is always -5 on this horizontal line. So if we look at number 8, we see that now we're dealing with trying to find an equation of a line that's perpendicular to x equals 8, and it goes through this point 1, -1. So again, if we draw what x equals 8 looks like, of course, it's a vertical line. And so we know that anytime we have a line that is perpendicular to another line, that's just another way of saying they intersect at a 90-degree angle. So we know that if we have a vertical line, and it's going to intersect at a 90-degree angle, that's going to be a horizontal line. So if we come up with the point 1, -1, so let's just say this is 1 here, and that's -1 there. Then of course, this line is going to have to cross through horizontally, and thus this particular line would be the line y equals -1. Because again, for horizontal lines, it does not matter what x is, y always has to be the same y coordinate. So answer to this question would be y equals -1. All right, so next we're going to talk about finding equations of lines where we're either given the slope in one point or we're given 2 points. In this particular example, we are given 2 points. So from what we know here, there's 2 different forms of an equation of a line that we normally use whenever we try to find out the equation of a line. One is called the slope-intercept form, where we know the m is the slope, and this little b right here represents the y coordinate for the y-intercept. And the other one is called the point-slope form. And so what I'll be doing is showing you how to use both of these forms to be able to come up with your equation of the line. You don't have to do both forms. It's just that some people gravitate towards one form more so than the other. you figure out which one works for you and just use it. So since we have 2 points here, we can label this x1, y1 for the first point and x2, y2 for the second one. And since we have these 2 points, we need to end up finding the slope of these points so that we can use that, because you can see in either form of the equation of a line, we need to know what the slope is to be able to find out the rest of it. So what we remember, we know that slope is equal to y2 minus y1 over x2 minus x1, or simply the change in y values over the change in x values. So if we plug in directly here, we see y2 is negative 11 minus, we see y1 is a negative 5. And notice how I put the negative 5 in parentheses there to make sure that I subtract this properly. My x2 is 6 minus my x1 is 3. So we know that subtract a negative 5 is the same as adding 5. And 6 minus 3 is 3. So it ends up being a negative 6 over 3, which is a negative 2. So we know here our slope is a negative 2. And let's make that look a little better. All right, so now that we have that, if we're going to use the slope-intercept form way of finding an equation of a line, then here we're going to use one of these 2 points here. I'm just going to elect to use the point 3, negative 5 and label that x and y. And my slope here is going to be a negative 2. And I'm just going to plug everything into the slope-intercept form of an equation of a line, and I will be solving for b, which is what the y-intercept will be. So if we do that, then we see y is a negative 5 equals m, which is a negative 2, times x, which is 3, plus b. And of course, we know that negative 2 times 3 is a negative 6, plus b. Add 6 to both sides, and we see that b is equal to 1. So now that we have that b is equal to 1 and m is equal to negative 2, we know that the result of this is y is equal to negative 2x plus 1. And that would be our equation of a line. So if we did the same thing using the the point slope form this time, then again, we can use either one of these 2 points. I've used the point 3, negative 5 here whenever we did the slope-intercept form. I'm going to purposely use this other point, 6, negative 11, to show you that we still end up getting the same thing, okay? I do understand I have this labeled x2, y2, but it really doesn't matter, okay? I could just as easily switch these and basically switch them around and have this one be the x2, y2, and this one be the x1, y1. So that part really doesn't matter. All right, so here I'm going to use the point 6, negative 11, where I'm going to just label this x1, y1 here, and my slope is going to be negative 2 again. And this time I'm specifically plugging in for x1 and y1, and I'm not going to plug anything in for x and y, okay? Because I'm using that to kind of get my form of an equation of a line here at the end. So when we start here, we'll just say y minus, and then my y1 is a negative 11 equals, slope is negative 2 times x minus x of 1, which is a positive 6. We know here that subtract a negative is the same as addition. And if we distribute our negative 2 over, that will be negative 2x plus 12, because a negative times a negative is a positive. And then we subtract 11 from both sides. That cancels to 0, and 0 plus y is y. And we have a negative 2x plus 1. And as you can see, we end up with the same exact equation as we did whenever we did it using the slope-intercept form. For our next example, this one is much easier than the one that we've just done, but it does require that you understand conceptually what is going on. So here we're asked to find an equation of a line, and we're given the slope, and we're given this value for b here. And of course, as you can see, the b represents the y coordinate for the y-intercept. So for here, we would want to use the slope-intercept form because the information that's given to us directly tells us, hey, we have a slope and a y-intercept. So literally all we have to do here is the slope is -8, the y-intercept is going to be a -4, and that is it. That's all we need to do. Okay. These types of questions could be also stated another way. You could have, instead of just saying the slope is -8 and b is -4, it can also be written as the slope is -8, and instead of saying it like this, they'll say you have a y-intercept at y = 4. That's one way of saying it. They could also say, kind of like how they're trying to do here, you have the point 0, -4 on your graph. So even though it's not explicitly telling you that that's a y-intercept, that's what it is. So if it's phrased either one of these ways conceptually, as long as you know that you have a slope and a y-intercept, you can directly use the equation of a line in slope-intercept form to be able to come up with that particular equation. All right, so let's look at number 11 now. All right, so for this particular question, we're given the slope and also we're given a point. So we can do just like how we did in question number 9 that we had earlier. And I'll scroll back up to that so you can kind of remember what that looked like. So we're going to be doing the same procedure here once we actually figure out what our slope is. So like what we did here, we had a slope and a point. Use slope-intercept form, or we can do it this way where we have a slope and a point, and we can use the point-slope form. So either one of those ways is fine here. If you notice, part of what we're asked to do here, something a little different. We're asked to put our equation in what we call the standard form or the general form of an equation of a line. So there's going to be an extra step here. I am going to choose to use the point-slope form to start this off, just because, that's what I feel like doing right now. But eventually I'm going to get my equation in slope-intercept form and then change that over from slope-intercept form to the general form. Okay. So if we look here, another reason why I'm wanting to use this is because the point-slope form can readily accept the slope and the point, then I'm ready to plug into it. Okay. Of course, my 5 here is my x1, my 3 is my y1. So if I plug this in directly, I'll have my y1 is 3, my slope is -2/7, and my x1 is 5. Okay. So from here, I'll go ahead and distribute my -2/7 to both terms here. So that'll be a -2/7 x plus 10/7. And so now from this point, remember I want it to be in this type form. So one of the things that I can do real easy to make everything not have fractions in it is I can multiply by the LCD of all the fractions. And since I only have 7 in the denominator, that means I can come and multiply both sides by 7, and that will get rid of my fractions. So I'll come here and do this. This will be 7y minus 21 when I distribute. Over here, when I multiply 7 times -2/7, these 7's here will reduce to 1. And all I will have left is a -2x. Same deal over here. If I multiply 7 times 10/7, those 7's reduce to 1. and all I have left is the 10. So when I do this, I just have the negative 2x that's left here. And over here, I just have the 10 that's left there. And so now from that point, I just need to get it to look like this. So I will add 2x to both sides. Let's get that looking a little better here. So we'll add 2x to both sides. That cancels to 0. 0 plus 10 is 10. And here, the 7y and the 2x are unlike terms. So that's why we will just write this as 2x plus 7y minus 21. And then, of course, to get it in this form here again, I need to have just number times x plus number times y equals c. So that means I would need to add 21 to both sides here. And this will now be 2x plus 7y. And on the right side, that adds to be 31. And so this would be my actual equation of a line in the general form. Okay? And so that's what is asked for here. Now, of course, if this had asked me, let's find the equation of a line in slope-intercept form, then I would not do all this stuff going over here. I would just continue on right here, and I'll just come down and write what the rest of this would look like. Of course, I would add 3 to both sides here, so this would be y equals negative 2/7 plus 10 over 7 plus 3, okay? And then, of course, I would have to change 3 to some fraction that had 7 here. And that would be relatively simple to do because the same as 3 over 1. Let's see if I can get it to right. And, of course, I would have to multiply numerator and denominator by 7. And that would give me 21 over 7 for that. And then that would end up being just a negative 2/7 x plus 31 over 7. So this is what it would be like if I wanted it in slope-intercept form, okay? But of course, this question started off saying that we just wanted it in the general form, which is here, or the standard form. So this is the actual answer to the question. But you may be asked to do a problem like this as well and have it in slope-intercept form. So I wanted to make sure I showed that way as well. So with this concludes the examples that I have for trying to find the equation of a line, whether you're dealing with horizontal line, vertical line, whether you're asked to do some of these things referring to a line that's parallel to one or perpendicular to one, as well as if you have the slope in a point or if you have 2 points and you need to find the equation of a line. I have another video for those of you that want to see more extensive examples on trying to find the equations of lines that are parallel and perpendicular to others that are not of the case where the line is either vertical or horizontal. I do have a YouTube video on that. Just search for parallel and perpendicular lines by Valdez-Gant, and you will see that it pops up. And just let me know if this is helpful. Thanks for checking it out. Take care.